Thanks for joining me. In this video, I'm going to be explaining how to simplify algebraic expressions, and we're going to start talking about a certain property that we use a lot, which is called the distribution property. So there are other properties that you can find, the associative property, the commutative property, the identity property, etc. But one of the ones that we really use a whole lot is the distribution property, and I think it's definitely worth naming, so I'm going to do so here. Let's start by defining an algebraic expression. So an algebraic expression is a collection of constants and variables joined together by grouping and operation symbols. So in a previous video, I discussed numerical expressions, and those are expressions that simply contain numbers only. Now, an algebraic expression, we're including variables in the expression as well. The first two, we're asked to evaluate each expression for the given values. So you see that we get an expression first, and then we say for y equals 5. So we want to substitute in the 5 for the y and see what we would get for this expression if we know that y is 5. So let's do that here. A good habit to be in is to put parentheses around the value that you plug in for a variable. And in this case, it does not make a difference. If we didn't have parentheses, it wouldn't be a big deal. We would know what operation to use. But it sometimes is helpful, especially when we have negatives that we're plugging in or there are exponents, just to be clear what is included in your variable, okay? So when we plug in 5 for y, we're going to plug in a 5 in every y we see. We get 5 plus 3 on the top and then 5 minus 3 on the bottom. And we're simply going to simplify. So 5 plus 3 is 8. 5 minus 3 is 2. And then we can see that we can divide that out, right? 8 divided by 2 is 4. So evaluating means plugging in a number or numbers and then simplifying, okay? Number 2, same thing, but here we have two variables. Notice we have an m and an n. So m is -1 and n is -2. So we want to plug those in. So we will have 3 times m is -1. Notice I'm putting parentheses around the number that I'm plugging in for m, minus n is -2. You might be able to see now already it looks kind of confusing, right? If it helps with colors, let me show you here. I'm going to use red for m. M is -1, and blue for n, okay? So I'm going to plug in a -1 for the m, minus, so everything in black is coming directly from the formula or the expression. N is -2, okay? And then all that is squared. Minus 2 times a negative n is -2. Okay, so this one, there is a lot of negativity here, right? There's a lot of negatives. So be very careful with your signs and figure out what you need to do. So first thing, let's look inside the parentheses. This set of parentheses, we could make a bracket if we want it to be less confusing. Okay. So within the brackets here, we'll have 3. Let's look what happens here. We have a -1, and then we have a negative and a negative. So this is minus a -2, but those two negatives can multiply together to give us a plus. Okay, so that's really -1 plus 2, and then we're going to square that. Minus 2, okay, again, we could make these into square brackets if we wanted. This is a -2, or you can think of it as the opposite of -2. These two negatives will make a positive, so this would just be 2. So that has helped a lot already. Okay, let's continue. So within the first set of square brackets, we have -1 plus 2. Those are different signs, so we would add, or we would subtract the numbers, and then keep the sign of the biggest. So 2 is larger than 1, so the answer will be positive. So it'll be 1 squared minus 2 times 2. All right, now we want to do the exponent. So 1 squared is 1. Okay, and I'm just switching to parentheses, but you can keep the square brackets if you'd like. Now multiplying and dividing comes next from left to right. So 3 times 1 is 3, minus 2 times 2 is 4. Now we simply subtract, and we would get -1. So when it says to evaluate for given values, you just plug the values in and then simplify. Sometimes, though, we will not be given the values of the variables. In this case, we are simply going to simplify as much as possible. So a couple of things we want to talk about. First is the distributive property. So the distributive property we use when we have something like A multiplied by a binomial. So this is called a binomial, B plus C. So bi means 2, and it has 2 terms. So B is a term and C is a term. So the addition sign separates the 2 terms. So this is called a binomial. In this case, you're multiplying A by everything in parentheses. So what you can do is distribute this and multiply each piece by A separately. And that's the same thing. So A times B gets you AB, and then A times C gets you AC. And you bring the plus over. So we will use this a lot, okay? The other thing we need to discuss are like terms. So like terms means that you have the same combination of variable or variables and exponents. So like terms same variable or variables and exponents. Okay, so that would be like 3x plus 2x. They both have an x, no exponents, right? So understood to be a 1 exponent. So you simply add the coefficients. 3 plus 2 is 5, so you get 5x. If you have 3 of something and you add 2 more of that same thing, you have a total of 5 of those things. That's adding like terms. Another example could be 2x squared y plus 2x squared y. What you look at is all of the variables and exponents, and you see if they are the same, right? Notice we have an x and a y in both of them. The x is squared in both of them. The y is just by itself or raised to the first power. So those are like terms. If you have 2 of those and you add 2 more of those, you get 4 of those. So you have 4x squared y. So both of those are examples of like terms. Let's look at number 3. We are asked to simplify each expression. So before I go forward, I want to make sure I show this site. So a lot of these examples or the wording may have come from the OpenStax textbook. So this is a free resource for students. It's a really good material to have access to. Here is the web link. If it is helpful, I would suggest going there, working through extra problems. They have a whole homework set, and the answers to all of the odd ones are given to you. So you may find that helpful. Okay, so let's go back to what we need to do here. Simplify each expression. So what we want to do is look for any like terms that we can combine together, because in this case it does not tell us what x is, it doesn't tell us what y is, so we just have to simplify as much as possible. So the first thing I see is this 3x. So I'm going to look through the expression and see if there's another x without an exponent that I can combine with the 3x. I see I have a plus x. So those are like terms. Notice the negative 2y is not like because it does not have the same variable. So the next one I see is a negative 2y. I'm coloring that in blue. I can combine that with the negative 3y. Those are both like terms, right? And then I have the minus 7 that's totally by itself, right? That's called a constant. It has no variable attached to it, so it's constant, and there are no like terms for that. And so now I'm simply going to combine my like terms. So 3x and plus x, that would be 4x. And then I have a negative 2y and a negative 3y. Those are the same sign. They're both negative. So I'm going to add the numbers and keep the negative. That would be negative 5y. And then I have the constant. So bring down the minus 7. Notice in my expression now, I have no like terms. So this is going to be my final answer. Okay, that is the simplified expression. Once you get to the point where you have no like terms, you've done what you need to do. All right, number 4, 2mn. So that's going to be in red. I'm looking for another mn combination, right? The negative 5m does not have an n, so that's not like. 3mn, that has an m and an n, so that's like terms. And then the n is not alike. All right, the next thing I see is the negative 5m. Well, the only thing that's left is an n, so that's not like, so that's separate, okay? So notice we have 3 different things here we're looking at. We're looking at the mn's, we're looking at the m's, and we're looking at the n's. So first I'm going to look at the mn's. So 2mn plus 3mn give us 5mn. And then I'm just going to bring down the minus 5m and the plus n because there's nothing to combine. And that's it. That is my simplified expression. So sometimes students try to make these harder than they actually are. They maybe will add an equal sign and start trying to solve. You can't do anything else. So don't overcomplicate this. You're simply adding like terms and putting it down as simplified as possible. That's it. Okay, number 5 and number 6, we're going to use the distributive property here. If you look at number 5, hopefully you can see what we're distributing. Okay, so what we want to distribute here is the negative, whoops, thought I was on highlight. Here we go. Negative 5. You always include the sign with what you're distributing. That's very important. If you don't include that sign and you just distribute the 5, your signs are going to be messed up. So make sure whatever sign is in front of that number, you include that when you distribute. So we need to distribute that negative 5 to each term inside the parentheses. That means multiply each term in the parentheses by negative 5. So first we're going to bring down the 2r. Negative 5 times a positive 3 would give us a negative 15. Remember, when you're multiplying integers, a negative times a positive is negative. And then negative 5 times a negative r, 2 negatives make a positive, so that'll be plus 5r. And then we bring down the 4. After we use the distributive property, and we have no parentheses left, we can now start trying to add like terms. So I have a 2r plus 5r, those are like terms, and a negative 15 and a plus 4. Those are like terms. Those are both constants. So now I'm going to combine my like terms. So 2r plus 5r is 7r, and negative 15 plus 4, that'll be negative 11. Again, The things in blue are different signs, so you subtract and keep the sign of the larger number when you ignore the sign, so negative 11. And that's it. 7r and negative 11 are not like terms, so you cannot combine those. So that's as far as you can go. That's your simplified expression. Okay, the final example I'm going to do for this section, we have 4t minus 5/4 s minus 2/3 t plus 2s. Okay, so we've got this minus in between the parentheses. That means this minus sign has to be distributed so that I can get rid of the parentheses. I'm not just distributing the negative. You could think of it as a -1 out here. So what you're going to do is you're just going to multiply everything in the parentheses by a -1. In essence, you're going to be changing the signs. So the first set of parentheses, I have nothing to distribute. So I'm just going to bring down what I have, and I can take the parentheses off. So 4t minus 5/4 s. When I multiply by -1, I will now have a negative 2/3 t and a negative 2s. So a very common mistake is you forget to distribute the sign to the second part. So it's going to change it, right, to a negative 2s. All right, now I have to find like terms. So I have a t, so 4t, and I have another t, the negative 2/3 t. And then I have a negative 5/4 s, and I have a negative 2s. So those are my like terms. So I'm going to combine them. Now, unfortunately here, I've got fractions, right? But I know how to deal with fractions. I can take a whole number, this 4, and put it over a 1. So it'll be 4/1t minus 2/3t. So that's my red part, right, my t's. And then I have minus 5/4s minus 2/1s. So remember, any integer you can put over 1. And then we're going to find common denominators for each part, right? The t's need a common denominator and the s's need a common denominator. You don't have to have a common denominator among all the fractions because you're not combining them all, right? Just the t's have to have the same bottom and the s's have to have the same bottom. Okay, so t, I have a 1 and a 3 in my denominator. So I need to scale up to a 3. So I can multiply 1 by 3 and I would get a 3, right? They would match. Remember, whatever you do to the first or the bottom of the fraction, you have to do to the top. So we would multiply by 3/3 and I would get 12/3t minus 2/3t. Okay, and then I have to do the same thing for the s. I guess I can go ahead and just finish the t's off if I want. So 12 minus 2 is 10. So I would get 10/3 t. 10 and 3 do not have any common factors, so I can't reduce that fraction, so that's done. All right, let's do the s's now. So I have a 4 and a 1 as my two denominators. So I'm going to be able to scale up the 1 to a 4 by multiplying by 4. Whatever I do to the denominator, I have to do to the numerator, so I can keep it an equivalent fraction. So I'll bring down the minus 5/4 s, and then this will be minus 8/4 s. 2 times 4 is 8, right? And the 1 times 4 is 4. And then I want to combine these. So I have a -5 and a -8. Since they're both negatives, I'm going to add and keep the sign. So that will be minus 13/4 s, right? Because 5 plus 8 is 13, and I keep the denominator the same. Now I want to look and see if I can reduce the 13/4. I cannot. So this is it. This is my simplified expression.